Okay, let's start. Today I will explain in short about our code SP20. So if someone of you have never opened this document, those will be at least informed about content of this code. And I will start about numbering. As we know, previously all our codes were called SNPs. Now they are called SP. It means that like combination of rules. And if you see name of the code SNP, most probably it gets old and you should find new one. You can Google it very easy and find substitution for this code. And for in this number, we, I mean, in Latvia, we usually say calling these codes by its first numbers. It's 2 or 3 digits usually. So, for example, this code loads and effects we usually call SP20. So everybody will understand that this is loads and effects according to their, let's say, ID number. This numbering means usually nothing, or only for guys who are creating this code. And the last number also important. This is the last. This is the date of the last update, and usually this number saying us that this code was more or less partially replaced according to previous ones. And sometimes we have updates called which are represented here. It means that some after this document was replaced, after this some revisions were executed about this document. So these revisions are of course less than the date, because usually when they change date, it means that 10–15% of this document was replaced. This means that some, let's say, 30 thoughts, 30 points were changed, because usually during the year these revisions number could be 2 or 3. So this is sometimes also important. And about numbering, I think that's it. Let's go ahead according to content of this document. Previously, I was thinking that maybe I should create a manual about this document, but in the end, I realized that then it's not make sense to make guide. I just point the most important position and highlight it in this document, so you can easily understand what is the most important and what you must take into account in this document. But of course, maybe I skipped something, but in the end, I will try to highlight all important for me points in this code. So first, usually it's general rules, explanation of meanings, and here, for example, general requirements. In general requirements, I highlight that design based of limit states consists of different groups. For example, in Eurocode and American code, you have 2 checks of your elements. It's service load state and ultimate load state. In Russian code, we call it a little bit different. We call it limit state 1 and limit state 2. Limit state 2 is SLS. Limit state 1 is ULS. But meaning of these limit states is totally the same. So here's written that we should calculate, we should design our structures according to the first group. First group, they mean first limit state. It's ultimate limit state. and we should take into account these points. We'll go to this point later. And for second group, it's written that coefficient for safety coefficient for all effects and loads must be equal to 1. And here is according to these numbers. So in our code, we have a little bit different also coefficient system. I will show you this scheme in few pages later. We have different coefficients with for loads and combinations as well. And we have also special combinations. Let's call it limit state 3. But usually, let's say that this is very close to ultimate limit state. This check for special loads such as earthquake, accidental loads, fire case loads, let's say, and other stuff. And for these specific loads, it's written that safety coefficient must be taken as 1 as well. So if our accidental load happens, we should take safety coefficient equal 1. So we should not increase for ULS this coefficient. It should be the same as for SLS combination. And next chapter is classification of loads. And in our classification, as usually in other classifications, we have permanent loads, which is self-weight, usually self-weight. What else? Walls. So everything what is constant. And here is written what is permanent load. So it's walls of part of facilities, structures, hydrostatic pressure, etc. So you can easily understand classification according to this list. Also, continuous loads. I think it's not continuous loads. It's translated incorrect. It's temporary loads. And this is temporary partition wall, equipment different, which is movable. Some pressures, flooring, flooring materials for storage, and temperature, wind loads. So everything what is changeable is temporary loads. And also our temporary loads are divided by long-term load and short-term load. So all these loads, these continuous loads, they translate as longitudinal loads. Let me add mark for this. I think it will be valuable. Long-term loads. Yes, this short-term load. Short-term loads is also this is long-term loads. It's not wind. Not climatical loads. All climatical loads are here, and also some equipment loads, but not the same equipment as here. This equipment is like crane loads, which are movable all the time. Some equipment with dynamic, etc., etc. So also life load is short term. And special loads, I think I will not cover this topic during this class because it's very complicated and it will take too much time for cover everything, especially that in this code these actions are not covered. We have special codes for seismic loads, for accidental loads, and other loads. Here is explosion in cause of fire and other. About combinations. Here I gave a short scheme about differences between American code and Russian code in coefficients. For example, L critical is L characteristic. It's a characteristic load. L design load. KF, this is safety coefficient, and CL is combination coefficient. So how it is executed in US code? In US code, you have only one value of the load, which you insert in finite element model. And according to combination coefficient, with combination coefficient, you are getting forces from your loads for service limit state and for ultimate limit state. It means that coefficient C2 consists two Russian coefficient. This is safety coefficient and coefficient for combination. You have uniform coefficient. How we have this in Russia? We have two options of working with finite element model. We can work with characteristic load and with design load. And every engineer must decide how he will work and put these loads in your model. So traditional way, how I'm doing and how I suggest to do for easier understanding, is to work with characteristic loads. You are inserting them in finite element model. According to these multiple loads, you will get service limit states. And in this case, coefficient, safety coefficient is 1. So we don't need safety coefficient. We are working only with combination coefficient. And we are checking for service limit state elements, our elements. If we are working with ultimate limit state, we must give the program safety coefficient for characteristic load to transfer these characteristic loads to design loads. And according to internal forces with design load, program will combine, will make combinations for ultimate limit states, including also coefficients for these design forces. And after this, program will check elements for ultimate limit states. And second way is the same, just we are putting these design loads to the model and not multiplying by coefficient. We are dividing by this coefficient. So this coefficient is higher than 1. This coefficient is less than 1. And from design loads, we are getting characteristic loads and checking service limit states according to these values. But for ultimate limit states, we are not, our coefficient is 1, and we are using only combination coefficient and checking our elements. So it's directly the same, just way how to use this coefficient is different. It's up to you, but I would recommend to use characteristic loads, because in our codes, all values are written as characteristic loads. So if you compare your, for example, payload in the model, spread it on some area, you will get directly the same value as in our code. It's easy to check and easy to understand, and also coefficients. These coefficients, safety coefficients, are the same. So you shouldn't divide, for example, for snow 1 divided by 1.4 and put this 0.71 coefficient for this value. I think it confuses everyone, but it's up to designer, of course. So let's come back to coefficients. Classification. coefficients here, combinations. So in this chapter, it's written how to create a combination from our loads. And it's written that basic loads is permanent, continuous, and long-term and short-term loads. So let's say that basic loads, this is all loads, basic load combinations, all combination except special. So in 99%, we are using only this formula. And even in special combination, we have the same basic load combinations plus factor value from special load. So pretty simple. Formula is a little bit creepy, but actually it's more or less simple. I will try to explain it. So it's written that PD is our constant load plus every long-term load with some coefficients plus summary of short-term loads with some coefficients. So in next pages, we will discuss separately for this part, for constant part, for long-term part, for short-term part. For continuous loads, for long-term loads, it's written that if we have in our combinations 2 or more long-term loads, every second and next load must be decreased for 5%. It's very easy. So please keep it in mind. And also in our code, it's written that we must consider the most safe combinations. So load with factor 1 must be the biggest one, the most important one. So we should decrease with, let's say, smaller factor, the most miserable load. For short-term load, this is the same. First load is 1, second load is 0.9, third, fourth, and next one 0.7. It means that our short-term load could not probability of happening all this short-term load at one time is very low. So that's why code designers are making this coefficient that they are showing us that they took this into account, and this happening probability is decreasing according to number of our loads. And after we got these coefficients for every load, we are coming to this formula and making summary of this load. And please take into account that this load, PL1, PL2, etc., must contain safety factor. So this coefficient we are talking about, these ones. So if we are calculating according to SLS, this coefficient factor is 1. If we are calculating for ultimate stress factor, we should take coefficient according to this page. And this and PLS, which was mentioned previously, must consist of this safety coefficient factor here. So this P is also must be calculated. But this is theoretically how it should be look like. So, but usually program is doing this automatically. So you must, after the program is creating their automatic combinations, you must check that these factors are created correctly according to this SNP factor, according to this spec code. Let's go next. I delete this this text because this is not actual anymore according to the latest version of the code according to some revisions. Next chapters are considering loads and their safety factors. For example, in this table, we can see safety factor for different structures and for soil. For example, for steel structures, this safety factor must be 1.05. For concrete, it's 1.1. For concrete, which is not ratio, density is less than 1.5 tons per meter cube, it must be 1.2. For if it is built factory material or part of the building, it must be 1.2. If this is poured on site, it must be 1.3, etc., etc. Very useful table. Actually, I put all important table and notification here, so you can easily find something according in this document. And also, I would ask you to check these factors all the time. For example, in one of our latest project, even Russian designers get a mistake and put incorrect these factors. And almost everything must be checked according to this code. Next one is for this safety factor for equipment, also stationary equipment 1.2, liquids 1.0, etc., etc. Very easy. And we are coming to the one of the most important table is uniformly distributed load. For example, we have a project stage of the project, PD Russian, and we are designing this building almost from the zero, from concept, and we should take into account some loads, and nobody should take these loads, distributed loads, from their head. We have special table with the list of different types of areas according to which we must apply this load. For example, for residential apartments, we must take 1.5 kilopascals. For offices, we must take not less than 2 kilopascals. For halls, this one. For libraries, this one. For different. For balconies, this one. For here it is written almost all types of our types of areas, and you should check it all the time. And very important thing, that according to this value, you must take safety factor. This is the mistake our previous designer of stage P before us made mistake in this case. So if our uniform load less than 1.2, less than 2 kilopascals, you must take coefficient. I will write with green to mark up. If our load is less than 2 kilopascals, we must take safety factor 2. If this is 2.5, if it is less than 2, we must take 1.2. If it's bigger than 2 kilopascals, we must take 1.2. Very important. Let's go ahead. Do you have any questions, maybe? Okay, if you have, I will answer it later. So this is load from transport vehicles. I think this is also considerably easy. You can understand it. I will not describe crane loads because this is very hard topic, and I think it deserves special lessons for this. And even in this code, not all the important points are described. This is only, let's say, 1/5 of the part which should be described, because we have also some guidelines about grains, and this is very, very hard topic to describe it in one lesson. And we are coming to snow loads. In snow loads, it's pretty easy, but there are some tricks. I want to how to say, pay your attention that in this document, standards values called as characteristic value. So I give reference about this, and sometimes it confuses me. I think the translator who translated this document, he is not technical guy, and he translated not fully correct. And also I found one mistake in this document, which exists only in English version of the code. So 0.7 is not correct value. It must be deleted, and full formula of this snow load is this one. And I also give some simplification for easier calculation, which we use all the time in our engineering works. For example, factor for drifting of snow from the building roof. I never use it. Nobody uses it. So please take it as one. You can use it only in case you need to decrease your snow load as much as you can. Only in this case. But let's say that in 90%, 95, 99% cases, everyone uses one. Also thermal factor for melting snow. Almost everybody is using one. So as a result, this formula consisted of 4 different coefficient numbers, is getting to only 2 numbers. It's mu and Sg. Sg is our weight of characteristic value of the snow loads for our snow region. And it should be taken according to 10.4 point. And Sg is should be taken from, it's written actually that Sg could be taken from this table, and also some special formulas, but everyone also is taken from this formula according to snow region. So you can Google snow region of your city where you have your location of your building, and take this value in kilopascals as characteristic load for your design. And second factor is mu. Mu is not very complicated to understand factor, and for calculating mu, we have special appendix here, snow load schemes, I call it. So here is different shapes of our roof and surfaces, but I marked only 2 of them, which I'm using only in, I think, 90% of our design. This is building with elevation differences. I call it building with roof drops. We have almost everywhere this calculation scheme when our snow is gathering in the angle of our roof, bottom roof. And for this case, I have special calculation utilized, which is also designed by me according to the latest code. It's opening. This one. You just need to write Sg, let's say 1.5, drop height 55, length of your upper roof, let's say 20 meters, length of bottom roof. Bottom roof means that if we are calculating, for example, this area, snow pocket in this area, this is our bottom roof. This is top roof. So from top roof, our snow is falling, and in the bottom roof, our snow is gathering. So it's not, and according to guidelines, snow pockets are usually gathering not because of drops from the roof. It is going from the bottom roof in the corner of these drops. So usually it depends on different conditions, and we are inserting these conditions values in this utility. So we are given width of our bottom roof. It is this one. For example, if this is our drop, this is plan layout. This is width. Angle, okay, usually it's 0. What else? This is also angle. This is height of our parapet, let's say 0.5. And as a result, we are, first of all, you can check everything according to these formulas. It is different formulas. You can check my calculation. And also you can get result for our snow pocket. It's written here. So our B length of our snow pocket will be 16 meters. Mu, this is coefficient, will be 1, and mu1 will be 0.95, 59. So very easy program, and you can use it. I will share it with you as well. So let's come to snow fact. Also, let's go to next streams. I marked also snow pockets from parapets. I have never calculated with some programs because this here is only one formula. You can easily calculate it with your hands. And also one formula for small squares, let's say, or rectangulars on your roof. For example, you have some mechanical room on your roof, and if your diagonal of this building is higher than is bigger than 1.5, we should take this stream for snow pocket and calculate this snow pocket as circle. It's written that snow pocket will get this strange shape according to this beta angle. But according to my experience and experience of my colleagues, we all the time we are using circle a lot because this angle beta, according to wind direction, could be different, and we are applying safe side all the circle from this shape. Also pretty simple. And the most important case, according to Russian code, actually according to Russian manuals, it's not written in code, and this is very strange for me. Our calculation of snow must be divided by 2 or 3 different types. One type is a regular uniform snow with mu equal to 0. We call it how to call it in English? Let's say uniform single snow. And for uniform single snow like this, where all the roof is covered with snow with coefficient mu1, it means that our snow will be value of snow will be Sg multiplied by 1. So it will be just Sg. And second case, we are considering our snow pockets. And this is 2 independent cases. This is very important because in some project, even in Russian in design of Russian engineers. They are combining this. They must not combine. This is two different cases, and snow pockets is independent case, and single snow is also independent case, and they are not combining anytime. Please take it into account. For example, here with single snow pockets, we can combine this single snow pocket and this parapet, because it's written that if we have mu1, we can take this snow pocket, but this snow pocket is very small. Usually we can skip it at all, but it's better to consider this snow pocket. But in this case, in case of drops, here, our mu1 is totally different. For example, here, in my calculation. In my calculation, mu1 is 0.7. So we should consider this snow pocket. In this case, I have in snow pocket with mu5, so near to the drop, I have 6 times more snow loads than in other, in regular roof. And with duration length of this snow pocket, no, I have 2.3, excuse me, 2.3. With length of my snow pockets is 6 meters. But in all other roof, my snow load is 0.7. This is very important, because otherwise, if we have snow pockets plus 1 coefficient for every roof, we will increase our snow load usually in 1.5 times. Don't do this, please. And also, sometimes if we have trusses, in our manuals, it's written that to correctly calculate diagonals of this truss in the middle of the truss, we must give snow load for left side of the truss separately, and right side is without any load, and to the right side of the truss. And by this way, we will get forces in the middle of the truss for diagonals 2-3 times bigger than for regular snow load. It sometimes also gets some effect. Let's go ahead. Do you have any questions about snow loads? Maybe. No. Okay. Wind loads. For wind loads. For wind loads, in our code it's written that every wind load must be, every building must be checked for design wind load. This is usual main part of the load. For peak load, but for peak load we are checking only parts of facet, let's say. Resonant vortex excavation, excitation. According to our code, we should not get these vortexes at all. If we get it, we should make some special shape of the building or special parameters. For example, if you have tube, we must give some screws for this tube for pipe to avoid from these vortexes. And aerodynamic unstable wind, it also should not be considered. This is usually for very specific structures, such as pipes, some electrical supports, very tall and very thin, and etc. And also for every type of load, for wind load and for snow load, we have safety factors. For wind and snow, safety factor is 1.4, as it's written here. Next one. It's written that our main wind load consists of 2 components. Basic wind load and pulsation part. In our code from 2016, there was only basic load, WM. But after 16 years, and everything was stable enough and nothing failed. But after 16 years, they include this pulsation value, and we are forced to calculate it as well. So let's start from basic wind. Basic wind calculating, we are calculating according to this load, according to this formula, W, KZE, and C. W0, this is standard wind pressure, which should be taken from this table. It also could be calculated by this formula, but this is very rare case. You can calculate, but I suggest you to use this table. This is more trustable results. KZE is a factor for changing of wind pressure according to height of the building. We'll speak later about this. And C is a aerodynamic factor, which must be taken according to the factor similar to the factor mu for snow, according to some special wind schemes. So W0 you can find here. KZE, how to find KZE? KZE is calculating by this point, and depending on the equivalent ZE parameter. And usually, even Russian designers, a lot of Russian designers are making mistake in this case. KZE, this KZE is not equal to ZE. ZE is just one of parameter to find KZE. And ZE must be taken according to this formula. And since our Russian codes usually written not for engineers, but for lawyers, as you know, I spent some time to create my own table to easy understanding of these formulas. So if we have building, our wind direction is like this. And considering these dimensions, width of our building perpendicular to the direction of our wind, and height of the building h, if our height of the building less than d, so our building is, let's say, pretty not tall building. We should use usual wind pressure according to the maximum level. So we are taking ZE the same as our height of the building. If our building is, let's say, square and less than square, I mean height of the building less than square. If our building is from square to rectangular but not very tall, we should divide our wind area for two different areas, for two different elevation, and calculate two different values separately. For height from 0 to HD, it must be D. So this is one not constant, let's say constant, not linear formula, constant value. And for second part of our building, where our elevation is higher than d h mean height minus width, we should take according to our top level of building. We should take wind value on the top and apply this value to the whole this area. If our building is higher than to width of our building, we should take more complex wind load and with 3 different zones. I will not explain you. I think if you stuck with this situation, you can easily calculate it according to my schema. So, and according to this scheme, we will find ZE. For every ZE, we should calculate KZE. And KZE is calculating here according to this ZE and type of our construction field. ADC, this is like it's written here. A is like C without any stops for wind. C coasts, water reservoirs, etc., etc. Area like without any borders. B is like city area. C is like downtown area when we have big buildings higher than 25 meters. And according to our ZE and type of the field, construction site, we can calculate ZE. And the only third factor is not clarified yet, C. For C factor, we should go to wind schemes appendix. This is appendix 5. And here we must find a scheme which is corresponding to our requirements. So this is for billboards, for example. This is for usual buildings. This is for another type of buildings, etc., etc. Different types of buildings. For with probability 90%, we are using this scheme, scheme V2, where we have direction of wind load and different areas affected by wind. I want to pay your attention on the one of the biggest mistake which designers are doing. I will draw it. Where is it? So if we have this picture, our wind is going like this. We have wind pressure here, wind pressure here. And most designers are thinking that this is okay, but it's not okay. Please take into account this area. It must be considered as well. So in every case, when we have one direction of wind, we must consider also this kind of pressure, and this kind of pressure. According to all wind manuals, our wind effect will expand all the time our building. It is not only one direction effect. This is 4 different direction effect, 3 different directions in this direction and 2 of this direction. So all the time our wind is expanding this building, and it will increase at least forces in our horizontal braces. Maybe it will affect, most probably it will affect also at another structures, but especially braces. Please take into account. So for this calculation scheme, it's written that for front wind, we should take coefficient 0.8. For side wind, we should take B or A or C. Not or. In the first part, it's written that A divided by 5, we should take this coefficient, this coefficient, this coefficient. and the same area for this, the same load for this. So we have four-sided load effect. And minus 0.5 means that this wind will go directly in this direction. So it is not going in this. This is opposite 0.5. Please take into account. And with these coefficients of D, E, A, etc. These are C coefficients. These coefficients of C factors, which is written here. So we found W0 from here, KZ from this table, and this table, and C factor from wind scheme. And only one thing we are not covered is WP, pulsation component. This is the most complicated for everyone component. And according to this code, let's go ahead. This pulsation wind component must be calculated according to the first natural frequency. So we should calculate frequency of our building, and if our frequency higher than ultimate natural frequency, we must calculate according to this scheme. If this we are forcing to calculate according to this, we are calculating to this formula, etc., etc. There are different how many types? 1, 2, 3 different types. But in different Russian programs, finite element software, we have automatical calculation of this wind load. For example, Lira support can do this. Some utilities for ETAPs can do this. So you should not carry. I mean, you should carry. You should check anything anyway this load. But instead of you, all this calculation program will do, and you should check just that this is taken into account by the program, and you should calculate it. So wind load must consist of two different components: this basic load and pulsation load. Please check it all the time. Usually for small structures such as technological platforms, secondary structures, let's say, I am taking double basic load for safe side, and do not check pulsation load. But for important structures such as residential buildings, for some huge structures, we must calculate it correctly. Let's go ahead. And the last load is a peak load for wind. Peak load is not pulsation load. If we have some fencing structures such as pahar structures, some sandwich panels, and all covering structures which are directly affected by wind, we must check them for peak load according to this formula. This formula looks very complicated, but by the way, this is much more easier than calculation for pulsation load. So I think you can handle it by yourself without any problems. Just one by one, they have extra coefficients which are calculating according to this SP. And this peak loads, as I said, this is not usually applied for all structures. This applied for let's say partial parts of our structures as additional load. And for also for this structure, for this load, usually yes, I calculate, I think, only factor structures and checking. Yes, I also checking usually corrugated sheet for this load. For so I'm checking for base load plus peak load. Not plus peak load, for base load separately and for peak load separately. And I'm choosing the biggest value and calculating on this value for corrugated sheet and sandwich panels as well. Okay, I'm not covering this. Ice loads also usually we don't calculate. We calculate it if we have, for example, some electrical supports with hollow structures. So for structures which are not affected by wind too much, where self-weight is small, we have big, let's say, covering area of our structures. This kind of structures must be calculated for ice load. For usual structures like square, we don't calculate. Next, temperature. I think for temperature also we should make some specific lessons because this is not usual load and not very easy. And in this code, not all important topics are expanded and covered and explained. So now in the end we have a lot of appendixes. This is snow. These are wind appendixes. Next ones will be some temperature for different and displacement. We are coming to displacement. In Appendix D, we have maximum deflections, which must be considered for SLS calculation of all our structures. For example, these are for crane beams, not very, it's important, but for specific buildings. These are for all beams. I marked it as important because and it's written that if we have span of the beam 6 meters, we must take our 6,000 divided by 200. So our deflection must not be bigger than 3 centimeters. And for 24, this is 25. In brackets, they have extra requirements, and this is written here that in brackets, if our height of the promises is up to 6 meters, we should take numbers which is written in brackets. So usually we are taking this parameter, first one. If we have very tall area, flat, very high flat, with high ceiling, then we should take into account this one. And also important point, very important point, that for cantilever beams, we should increase our span for our beam. It means that if our cantilever is 2 meters, and for 2 meters, we should take 1.35 between 120 and 150. We must increase, we can increase this span for 2 and get our deflections the same as for beam with length 4 meters. you can use it for some cases. And this is horizontal deflections. Also, I think it's common for all codes, like considering one story of multi-story building and a multi-story building altogether. And in the next, we have maps with snow areas, wind areas, temperature areas, different areas. But in, to be honest, in our actually in our last code revision, we have this kind of table instead of these stupid maps. Everybody hates these maps. So they at last wrote that for characteristic load of snow, they have name of the city and have they have value for snow loads. So now it became much better. But this code a bit old, not too old. I mean, this is dated by the same time, but revision the same year. But revision is not the last one. And at this time, that's it. If you have questions, you can ask me. Do you have any questions? Everything is clear? Go ahead.
My first question, safety factor and combination factors about.
What exactly?
I mean, start of this presentation, we are talking about the combination factor and for characteristic load, yes.
Okay.
And there will be safety factor also.
This one is safety factor KF. Actually, this KF is it call it gamma F. This is safety factor. I call it, okay, maybe I wrote not totally understandably. This is gamma F. This is, let's write here gamma F. This is gamma F.
Okay.
Mhm.
In this case, I can see the list forces for the characteristic load.
Okay.
So if you use the design load according to this regulation, how can we change the characteristic load, or where is the design load?
Look, if we are using design loads, it means that our safety coefficients will be less than 1. So if in this case our safety factor is 1.4 for, let's say, for wind, here it will be 1 divided by 1.4, and it will be 0.72. And for this case, if we put here, for example, if you put our force 5 kilonewtons, and in this case, and we will get here 5 multiplied by 1.4, it will be 7. Come on, 7 kilonewtons. Here we will give 7 kilonewtons, and 7 kilonewtons will be multiplied by 1.72, and it will be also 5 kilonewtons. So in the end, we will get the same value, only this coefficient is different. So in this case, in finite element model, you will give, you will assign 7 kilonewtons for your load. For if you want to insert in your finite element model characteristic loads, you will put 5 kilonewtons. Only the coefficient is different. Now it is clearly explained. or I can explain somehow in different words.
For example, in bottom of the sections, all sections say this node is the characteristic node.
Where?
Page down, please. Every page is mentioned the characteristic node.
Where? It's all loads in all tables in our SP. They are written for characteristic loads. This is safety coefficient to transfer characteristic load to design load. Or I not clearly understand the question.
Okay, I will answer later.
No. Actually, this is important for maybe your question is important for other attendees.
I mean, if you use characteristic forces, so if we can use the different coefficient
For different coefficients, yes. For combination. For these combinations. For this.
Yes.
Yes.
This combination coefficients are for characteristic node design mode.
These coefficients for all. Let's say that, for example, for combinations, you see in this chapter, it's not written for which loads, for which exactly design or characteristic loads these coefficients. It means that they are applied, for example, if for long-term load, this coefficient 0.9 multiplied by, let's say, P1, this is wind load. And for design load combination, for ULS, it will be like this. I will write ULS. But for SLS, it will be like this. Coefficient is the same. I mean, coefficient of combination is the same. Coefficient for this is combination coefficient. This is not. That's why I make a point that this P, this call out. This P could be P characteristic. It could be P design. It doesn't matter. This is P. This is uniform P. And when you after program will start create combination, it will give coefficient factor. So this is directly the same order of actions. First of all, program will calculate characteristic loads and design loads. Characteristic loads, design loads. After all loads are assigned, program will calculate according to number of types loads, number of short-term loads, number of long-term loads, number of constant loads. It will give this coefficient to every load, this load, characteristic load or this design load, and create this combination. So this coefficient and this coefficient is they are not dependent on each other. It's totally different. My idea is like this. Actually, this is the scheme how program is creating combinations for ULS and SLS. This is these coefficients for combination are independent.
Okay.
I see that I explained not clearly. Okay.
Okay. Second question. Snow cases short-term load.
Snow pocket, not accidental, it's short-term load. All snow loads and even ice load are short-term. Accidental loads is really accidental loads. When you have earthquake, you have explosion, you have fire case. So it's, your some car is crashed within your column, building collapse. So actually, special, it's called here special load, but it's clearly understanding accidental loads. You are right. Pockets are usual combination as usual snow. Just snow consists of different types of snow. With snow pockets with a single when mu is 1, and maybe some specific specific cases such as with these trusses when we have half snow on no snow on the half of the truss. That's it.
Thank you.
You're welcome. Any other questions? YouTube, go ahead.
Hello, do you hear me?
I cannot hear you. Can you come maybe? In this case, I can.
I'm talking about combination option 1 and option 2. Which one we use or how we decide?
Which one is the first, second, and third, right?
Yeah, option 1 and option 2.
Let me open this combination.
Yes.
I think this one, which one is 1 and second, third, right?
Combination table you created. Yes, here. Which one use this?
It's up to you. If you want to operate infinite element model with design values and put infinite element model design values, you can do this. But you must consider that your coefficient will be less than 1. If you are working with characteristic loads, then you should write characteristic load and multiply by coefficient higher than 1. So it's up to designer. Nobody is saying do according to first option or second option. It's up to designer. But I would recommend to use first option because all values are in our code. For example, snow loads. Here is the table. And when you write that in, for example, in St. Petersburg, you have 1.5 kilopascals on the roof, and
Yes.
you will see that this is 1.5 kilopascals on the roof. You can easily understand that this is a characteristic load. But if you see that this is this load is 2.1, you will get some questions. You need just to understand what is. You can calculate, of course. You can just make like this, but it's not clearly that this is not, for example, fourth snow region because 2.1 and 2 is very close. So I would recommend to use characteristic loads because this is easy to design with another partners. For example, if we have different buildings and you're calculating one part, I'm calculating another part. Of course, we can agree about which values of the load we are using. And this is important because in another case, in your report, calculation report, you will get value 1.5 as inserted a load. I will get 2.1, and there will be additional questions. So I would recommend everyone to use characteristic load, but it's up to designer. If everyone in our company will agree that we will use design load, okay, no problem.
Okay, thank you.
You're welcome. Any other questions?
Have we talked about
Yusuf, I can accidentally I cannot hear anyone. I don't know why.
you cannot?
If you need something, you can. Microphone. I see. I think I fixed this issue. Okay. What's your question?
And we talk about this duration factor.
Duration factor for SLS? You mean that we can decrease this for SLS low for 50% snow?
Yes, sometimes we are using just in SLS this duration factor side for the combination.
Yes, you sort of mentioned in some case important point that in our code it's written that for SLS combination we can decrease our snow load for 50%. And in some cases it gives us a good benefit for with some structures. And if our limit ratio, if our element is calculated according to SLS factor, we can decrease snow load and get more economical solutions for our calculation. But where is it written? It was written somewhere, I remember. Yeah, here. Here. Somewhere here. That's written. In English version, it's not very clear. Maybe in the newest version, it's written. Yeah, in newest version, it was written from the right side of the table. For building. So if you need to decrease snow, I will mark this information in my document. I don't want to spend your time. I will mark this info with highlights. It was written somewhere in this table, in some table from the right side. I remember. I will mark it.
We are decreasing load with this duration factor.
Huh?
We are decreasing load with this duration factor.
Yes, we can use different. We can put in coefficient. For example, if our this coefficient this if you, for example, if you are working with design values, and you are calculating SLS with some coefficient, and your KF is ratio is 0.72. In this case, we can divide it also by 50%, multiplied by 50%, and put this 0.36 for this coefficient. And by this way, our characteristic value for this snow load for SLS will be less, and we'll get correct result for checking this element for SLS. Or but if we are working with this, there are two ways. One of the way is decrease this 5 divided by 2, and put instead of 5 2.5 and multiply by 1.5. But I do not recommend it. In this case, I would suggest you to work with combinations. And in this combinations factor for snow, I would recommend to put not, let's say, not 0.9, 0.45. So it will be 0.45 factor, like this. Different ways, but you can use anyone. Any other questions? It looks like my microphone gets much better and I can hear you.
No,
Okay, you can
gamma table.
gamma F table. And there are different tables. This one for structures and soil, but the most useful for example, metal, concrete, and
I mean, this we increased with this coefficient loss.
yes,
But in the graph, for example, the different blocks increase by different coefficients, like 1.2, 1.1. There's a
yes.
difference
So yes, but look, for concrete it's 1.1, for metal it's 1.2, um, for insulation it's 1.2. So this like sandwich panels and other insulation
This is about the material or the load?
for
Load type.
equipment and materials. You can use it for liquids, for suspensions, for different things.
I mean, for example, there's a when you select the load case, for example, long-term load, it is written like long-term 1.2, coefficient 1.2, 1.1.
Okay.
How can I know this load is long-term? I know this one is long-term, but how can I determine this 1.2 or 1.1 or 1?
For example, can you give me any example of your work from which work? For example, if you have sandwich panels or not sandwich panels, for example, we have gas block wall, partition wall. We are coming to this table. We know that our density of our partition wall is less than 1.6. So it's not concrete structure. So let's say that this is some structures close to concrete, and this is less than 1.6. We can go and we are coming to understanding to the build factory load or manufactured in construction. Gas block is manufactured in construction, so this 1.2. If we have finishing layer for concrete, this is screed, and they are covering 2 centimeters of screed. This will be also these structures with density 1.6, but this is manufactured on construction site because they are making all this liquid from on site. So we are taking 1.3.
Because of the high error the factory, it's less.
Yes,
Yes.
because on site they can mess up everything. And
For example, we have coefficients.
for example, another example, I understand your question. Another example, this table for distributed load. If we have residential apartment, this we should take 1.5. If we take 1.5, our coefficient is less than 2 kilopascals. We must take 1.3 coefficients. If we have offices, this is 2. It's written that if this is 2 and more, we should take 1.2. So for this, we should make we must take safety coefficients 1.2, etc., etc. For all types of building, payload must be taken from here, and all these coefficients are can be considered more or less easy.
For example, we are determining some layer materials for coefficient.
Each layer. Isolation.
Yeah, then we are looking, for example, the density, which depends on density
Yes.
region, and we are determining.
Actually, for isolation, it's written here. For isolation, it is written here. For isolation, it's written here. If you are asking, for example, we have plastic facet. This is not isolation. Actually, this is also isolation. We can take 1.2. But if you get some very specific materials, you can take this coefficient in safe side. In safe side, usually it's 1.2. For materials, it's 1.2 as you can see. You will not get bigger. If our load is less, then according to this. So, any other questions? Okay, so if you have some other issues to discuss, you can contact me directly. I will answer. I will try to help you. So thank you for attending and have a good day. Bye.